Hello everyone, today we're doing chapter 12, problem 14, and this problem gives us this structure, this keto tautomer, and it asks us to draw two different tautomers of this 2-methylcyclohexanol, and also draw two constitutional isomers that are not tautomers. So let's start with A. So two tautomers. So in the previous question, question 12, chapter 11, question 12, we figured out how to go from an enol to a keto. So the converse is true for the opposite. So in order to go from a keto to enol, we need to look at the carbons directly adjacent to this to our ketone. So we have two different carbons directly adjacent to our keto, and we have two protons, or actually four protons, coming out of both these carbons. So we can actually go backwards and actually pick up the proton using this oxygen nucleus being electron rich. We can pick up one of these protons, making a new bond. When you make a bond, you break a bond. So the bond breaks is going to be the sigma bond. Sigma bond will form your pi bond, making a new bond. When you make a bond and you break a bond, so the carbonyl bond will break going up to the oxygen nucleus. So this forms one possible enol with the alcohol here. Double bond on this side. But then we have another adjacent carbon with a proton on this side. So alternatively, the oxygen can pick up this hydrogen atom, making a new bond. You make a bond, you break a bond to make the new double bond here, the new pi bond here. And when you make a new bond, you break a bond. So you break the carbonyl bond, connecting the oxygen. And then you form your second enol form with the pi bond here. So now you see we have two different enol tautomers, with one being the pi bond to the left of the alcohol, one being the pi bond to the right of the alcohol. So for B, draw two constitutional isomers that are not tautomers but contain your double carbon bond and your alcohol group. So remember, a constitutional isomer has the same chemical formula but differ in their bonding and connectivity. So we need to draw isomers of this molecule that has the same chemical formula but different in bonding, but have your alcohol and your alkene bond. So we can actually just use the two molecules that we generated here. So for B, we need same chemical formula, so it needs to have same number of atoms and hydrogens, oxygens, and carbons as this, but they need different bonding. So the easiest thing you can do is just move over your pi bond. So I can move over my pi bond down here, for example. So by moving your pi bond, you now change the connectivities of your atom, and therefore they're constitutional isomers. Alternatively, I can move this one over here. Now I have two different constitutional isomers, a different connectivity, but with the same chemical formula. And they satisfy all the conditions asked in the question stem.